Thank you all for joining. My name, again, is Sean Romero, and I'm going to present to you today two pretty amazing opportunities that we had the benefit of exploring with a particular customer. And today, the two things I really want to focus on is the concept around this solution. It's a prepackaged model. So we want to try to minimize the downtime and the startup time for getting projects off the ground and going by prepackaging a set of logic, code, instructions that are easily configurable, so a customer can just load their data, make some configuration changes, and then execute model capabilities. The other opportunity is we had a customer who they received approximately 30 to 40,000 applications per month for food assistance. The SNAP program is how it's commonly referred to. And in the process of that, in the process of doing that, the eligibility process is a means-based. It's a means-based program to determine if you're eligible for food assistance or not. And there's errors in that process. So increased errors over the years have gone up since COVID. And right now in the United States, there's about $8.7 billion in overpayments. So when someone applies and they're determined to be eligible for $500, the system could say you're eligible for $700 or $800, and that delta is an overpayment. And that provides a massive burden on the client because at some point those systems will catch up, they'll realize their error, and they have to go back and claw that money back from people, and it's a major problem. And so a lot of lost funds associated with this program. So right now the national error rate is somewhere around 10%. Which again is about 8.7 billion. So what we want to do is we want to build a tool that can go and assess the population of eligible participants in the network and determine the most high-risk cases that if they were sampled, they're likely to generate or yield an overpayment or a payment error. So what do they do today? Almost anything you could ever possibly want to achieve with a SQL query has been done. There's no more room left to go. We've SQL'd this data for the last 10, 15 years for reports, generating reports. SQL has a decay. A report may work very well for a month or two, and after a while it starts to have diminishing returns. So what we're trying to do here is we want to run an experiment to see if your own data can be used to build a model to do multivariate analysis and step away, move away from SQL and move more into machine learning. Conventional wisdom in this space is we need third-party data to solve this problem. So if it's a self-reported eligibility and enrollment system where people report their income and their expenses, conventional wisdom is we need third-party data to independently corroborate that. So if what they tell us is at face value, we have to take it on their word and process the application through, and that's the benefit amount, and that's what it is. And until we get other information to determine they're not eligible, they're eligible for a different amount, then we just have to go along with it. So the analysis here, and this is more of a research project that we started a couple of years ago with the state, was to ask the question, does your own data for your own self-reported applications in and of itself provide you with any signal that you can use to determine what are the most likely cases that have an overpayment? So here's how we do it. Most states, when they run an eligibility program for SNAP, they have a very common set of data collection points that they have to go through. They have their case data, where the recipient lives, their address, again, their income and expenses that are self-reported. They run it through a formula, a very deterministic formula to determine eligibility. And then if you're eligible, you'll get an issuance once a month, traditionally. And over time, states will collect data about improper payments. Somehow, some way, there's an investigative unit or a recovery unit that will work cases that are referred to them. They'll look at the facts and circumstances. They'll find other information that contradicts that, and they'll document, well, this person was receiving $300 a month assistance, but they only qualified for $100, or they didn't qualify at all. So that's a documented instance of an overpayment. So they're sitting on that data now. The investigative units are generating that by the hundreds or thousands across the nation on a daily, weekly basis. And so we want to say, can you use that data in any meaningful way to gain insight about the general population? So this process, when you feed these sets of data sets in, we'll validate your data, run some perfunctory analysis on it. We'll identify prior known bad improper payment patterns in your improper payment history data set. And then we'll build a couple of different prediction models inside this code base, choose the champion model, and then we'll score your population's data on the other side of it. All right, so when you come out of this process, we're going to have a set of VA reports to give you a very deep clarity as to what happened, how the diagnostic assessment ran of your general population, and what cases are the most high-risk cases. So let me, with that, let me come over here. All right, in a second, I'm going to do this demo live. So I'm inside SAS Via, and once the data sets are loaded, we have a data dictionary that we supply the states for the table structures that we want to see. Well, once your data is loaded, we use a thing called custom steps, which are a really great tool to just get you off the ground and running without any coding necessary. So in this interface, we've configured the drop-down boxes to load in the data sets that we need to look at. So in this case, to run this model, we're going to take your training data set, which is the outcome data from prior investigations. You're going to map over to the target variables in your file, and this is a very intuitive interface. It'll just map all the fields that are in the data set that you loaded in, and you just pick from here what you need. And then lastly, you're going to tell us what the scoring, what the new month data looks like, your new data that we want to score with the model. And when that comes out and runs, you'll get the diagnostic assessment of your population, where we drew our parameters for peer grouping, because one of the most important things that we found is that the data as a standalone unit of value on a row isn't enough signal. We found that if we peer group the data by geography, house size, and other independent variables in the eligibility data, that we can tease out a deeper, more powerful correlation. The second diagnostic information you're going to get is what ended up becoming the most important variables in the predictors for overpayments, your variable importance, correlation matrix, and then your model fit and your AUC data to understand how well the test data and the train data was able to separate and identify high-risk cases. And last, if this is working as it's supposed to, resources are very limited. So the investigative units have thousands of cases to look at, but they only have so many investigators to do the audits. So our goal here is to take a state's error rate, which in some cases could be 13–14% improper payment rate, and get it down to below the national average, which if you're a state and you're running around a 4–6% error rate for this program, you're doing very well. We have found, and the other thing I want to mention here is when we produce the report of who the high-risk cases are, each case gets a standalone p-value for the likelihood that if you were to audit this case, you're going to find an overpayment. And we categorize the entire population of your caseload in the breakdown over here. So what this is telling you is that there are 512 cases that have a 94% chance that if you were to select them for audit, you're going to probably find an overpayment of some kind in this case. And your average for your state at this point is 6%. And then down here, given the fact that auditors are very limited in time and states have more or less just a few people that have to work on processing these cases, depending on your bandwidth of how many investigators you have, you would just slide this slider right here to filter this down. So if you only had enough resources to work 500 cases a month, you'd want to slide this down and see, this is my list. Pull this list out, hand out those case numbers, and you can get to work on those cases. The other thing about this that's really important is you don't know when you go in front of the legislative body and ask for money, funds for your program, just how deep and how wide the problem is. Could I ask for 4 resources or 5 or 6 or 7? This report card essentially gives you a diagnostic view, a holistic view of your entire population. So we're finding really good efficacy in the scores right now. So if this 512 cases that have a 94% chance of error, 9 out of 10 cases we're usually finding that to be true in the real world. And so depending on how many cases you have or how big your population is, you can use this as sort of a statistical report to kind of bring to your legislative body and say, listen, if I had 5 more investigators, I could yield X, Y return on investment to work that population of cases. So that was faster than 20 minutes. Any questions? Does anyone here work for the, oh, there you go.
Hello?
Yes.
Yes, you mentioned a lot about overpayments in this system and like the possible repercussions of that and people like and agencies trying to like find ways to get money back. Now, on the opposite end of the problem, what happens if there's an underpayment for people who might need SNAP assistance? So let's say like you get $200, but they might actually need $500 or $600. What happens in that scenario?
So we haven't tested it yet, but we can definitely see in the distribution of risk scores that there's a mirror image opposite score of the likelihood that this case is misreporting their expenses in some way, that they're probably underreporting their expenses. And you can see on the distributions when those come out that those are most likely the underpayments. We haven't tested that yet. And right now, given the prolific nature of how much overpayments that are out, so I would say for every $100 for every dollar of underpayments, it's about $100 of overpayments, right at this particular point. But you're right, it is we were able to kind of see signal from that particular situation right now, but again, we haven't tested it. Does anyone here work for a Human Services Eligibility Means Tested program right now? Okay. So what we're finding is that if your application data, if you're taking applications for any eligibility program, before you go out and look for third-party data, which is a very expensive endeavor, if you have basically self-reported data for income and expenses that are the rules-based engine to determine eligibility, I would certainly look at your own investigative outcome data first and to see if you can yield any value from that before. And if you're using SQL now today to try to look for this and run different reports of that nature, there's definitely opportunity to run a model against that data. All right, I think that's it. I'll be done fast. Oh.
Yeah. In the data, are you able to distinguish between like the different reasons for overpayments? Like, can you distinguish someone who committed fraud from someone who made an honest mistake filling in the data to the organization itself making a mistake?
So models can't predict intent. We have no ability to understand the nature of the source of the error, whether it was a malevolent actor trying to supply fictitious information or just they know they're supplying false information. So we can't measure intent. But what we do see is a correlation between more of the cases that are in the higher risk zone for overpayment tend to be referred to fraud for investigation. So in, I would say 10% of all overpayments that are investigated end up getting referred for fraud investigations. The other 90, it's a mistake in the application, it's an honest mistake, it's a mistake on the processing of the agency itself, so it was their fault. Things like, so they call that agency error or household error. But about 10% of those cases will be referred for fraud.
And predict which of these cases will be what type beforehand?
Not at this point. Right at this point, we're basically saying the preponderance of evidence of where of what we see on this application looks like most of the other applications where you've recovered money for one reason or another. Every once in a while, some of the applications are just fake identities, just someone filling out online, sending in applications with a bot, things of that nature. But for the most part, it's just someone just not disclosing the information properly or a mistake by the agency.
Thanks for this. You mentioned this is prepackaged for the food assistance. Is this a model that you can replicate elsewhere, or is this purely built for just the food assistance program?
So I can't say it can be replicated anywhere, but I can say if you have a application enrollment system that uses means-based tested inputs, income, expenses, things of that nature, I would think you could. I would like to try it on that, but right now for this program, this particular model is tailored to this particular program, but it could be opened up for any application-based.
I was curious, this is something of a follow-up on the question regarding being able to tell the fraud from unintentional input of incorrect data. I was curious if on your roadmap you'd see any opportunity to then use this data to identify where there is a lot of unintentional input of incorrect data and then have that feedback. I mean, this is in some ways above all our pay grades here. This goes back to policy, but then to have that feedback into the actual application process, because then you've got a win-win where there's so many fewer people. If you identify an area where this is either just, in the simple case, super confusing in a way that where the UI could be different, or in the more complex case, look, nobody's, regardless of the UI, nobody's able to answer this well. Let's just find some other proxy for this type of data.
So what you mentioned is really important because I often see government agencies make policy decisions in the dark, completely in the blind, just based upon their current information they have right now and whatever disaster is unfolding in front of them. They'll say, well, it would be better if we just did X or we just did Y. But then you fall in the area of unintended consequences. So you cannot prevent what you cannot detect. So prevention's downstream from detection. And if we're starting to see efficacy in the higher end scores, the next phase of development is to, if we know that there's a 90% chance that this case has a problem, let's go ahead and derail that application and send it off to, when it comes in on the front end, before we send out the issuance, let's derail it on the front end for a few extra days and have a few extra time to process it. Without knowing that, implementing that into your front-end production system, you might derail 20% of your applications, 30, 40, 50%, and then you've got another set of problems to deal with. So, but you're right, ultimately where we want to go is move this onto the front end of the eligibility and make sure the applications that are correct can speed through and get the benefits they need and get them out the door. Because this program particularly has a 30-day clock. So once an application hits, they have 30 days to make an eligibility determination and get it out. And they like to be done sooner, and there are penalties if it takes them longer. So two outcomes from here is we can derail a small subset of applications for further processing, but still keep it in that 30-day window, and then have a fast lane for a whole bunch of other applications to just move through and get those benefits out the door as fast as possible. So those are the next steps that we want to do, but we don't want to make a move on the front-end system until we can measure with reasonable accuracy what's going to happen.
So as a follow-on to his follow-on, if you're capturing the agency error data, are you able to kind of use that as a feedback to training, or are you able to capture at that level?
So the front-end systems that are running these application engines, they're massive. They run the system for TANF, Medicaid, SNAP, child daycare systems. They're massive systems. You don't want to fool with them. Like if they're not broke, you don't want to touch them. But what they are finding is we may find a whole set of error, in one particular group. So the distribution of the cases that are in here between, I would say between 12% error and 94% chance, every once in a while, see like we have a really reasonable number for each category, 400, 400, 400. The first time we ran this in the 70th percentile of likelihood of error, we found a bulge of about 2,000 cases. And they all had some systemic break point in the application process when the eligibility, in this situation, their eligibility system was doing something wrong that they never caught in QA, and it was messing up one of the inputs, put it that way, without going into too much detail. And they could see that in the distribution of the scores. So if there's random error, random mistakes, you should see a reasonable distribution of the number of cases that fall into the different risk categories. But in this case, there was a systemic error that was occurring. So we were able to see it from that angle. Yes.
Thank you. So I think this does a great job on the eligibility side, but the flip side of the coin, once you get into the transactions, what you see is a really lot of fraud on that end. So has there been any concept of around a model around the post-eligibility, so once you're actually in the system, to identify fraudulent transactions that way?
So those fall into two categories. A real person who's really eligible, gets a card, uses it in a completely normal way, and then one day decides to traffic the card. So in this industry, when you abuse the benefit or you liquidate the card for the cash on the card without using it in the prescribed way, that's called trafficking. And we have a whole host of, we have a battery of analysis that we run against EBT data to look for that abnormal utilization. It takes two in that scenario. It takes a retailer and the participant to engage in that crime. On the other side of it, and this is more of a new phenomenon, card skimming, where they leave devices when you swipe your card to track your PIN number and get your numbers off of it. And then they liquidate those cards in some way, shape, or form. That's a massive problem today right now. And similar to how the banking system will run transaction analysis on all of our own debit cards and credit cards to signal you when there's a transaction that's occurred that they don't think is you, or you think your card's been compromised, that same set of technology can be used on the EBT data. I haven't done one of those projects yet. I think we may be have an opportunity to work on one soon, but we do have a lot of experience in the retailer fraud section, where retailer will just go at one day for whatever reason they'll start trafficking, and it's about 50 cents on the dollar for this crime. So if you have a $100 card, they'll swipe it, you get 50, they get 50. Problem with that, and a lot of the ways they get caught over time is someone's going to tell someone, and someone's going to traffic their card, and then another one, and this gas station that's doing 20 grand a month in revenue is now doing 180 a month in transactions, so they're going to stick out like a sore thumb over time. But that problem it's still pervasive, and it's still out there. The detection for it has gotten a lot more sophisticated today. So they're moving to other means as well. All right. We're good. Thanks, everyone.